All right, this is the Algebra 1, Unit 6, Lesson 6 video lesson. This lesson is kind of getting us into the next part of dealing with quadratic functions, quadratic equations, and which is to find the solutions. So when we talk about finding the solutions of a quadratic function or quadratic equation, we might also call that the roots, the x-intercepts, or just intercepts, or also the zeros of. All of these refer to the same thing. And what they refer to is when I'm looking at the graph of a quadratic function, I'm talking about these points right here where the graph crosses the x-axis. Those are all names for this thing that you see here on the screen. So all quadratic functions fall into one of three categories. Either they have two solutions, one solution, or no solutions. And I'll just show you a basic sketch of what those each look like. A graph that goes like this has two solutions. A graph that goes like this has just one solution. And a graph that goes like this has no solutions because this graph doesn't cross the x-axis. So we're going to be dealing with all three of these types, but we're mostly going to be relying on our graphing calculator. So let's open that up real quick and go to Desmos, and let's talk about some functions that fit into those different categories. So for instance, we might have y equals x squared minus 3. Well, looking at that, I have y-intercept here and here. Now, those are obviously decimal answers, but you can see how they have or x-intercepts in these two spots. Again, also known as roots, also known as intercepts. We might also have a function like this one. One minute. Not what I meant to do. Let's go back here. Oops. Here we go. X plus 3 squared would be an example of one where we just have a single x-intercept. This graph comes down, it touches the x-axis, and then goes on its way. It only touches at a single spot. That would be an example of a graph that has one solution, as you see right here. And then, of course, we could have graphs that have no solutions. I'm just going to add 7 to that, and you can see that this graph doesn't ever come down and cross the x-axis. It doesn't ever get there, so it doesn't have any roots. So those are our three possibilities. And so you can see how the Desmos system will help us do this. So let's just say we're looking at an example. And we'll use their example right here. We have x squared minus 7x plus 6. X squared minus 7x plus 6. Right away, I can see, based on the Desmos graph, that I have x-intercepts at 1 and 6, which if you look back at the lesson and the example, that's what they got for their solutions. The zeros of the function are 1 and 6. And they go through some other examples like that. But generally speaking, if you can graph the function on the coordinate plane, you can see how many solutions there are roots, intercepts, and you can also see what they are by looking at these points on the graph. And you should be able to do the same thing on your Desmos calculator as well. So, number 1, number 2, those are going to be vocabulary words. I've talked about this information both in my lecture, and you can look at it in the above reading. Then we see here, find the roots by looking at the graph. They've already graphed it for us. So then all we have to do is find those roots, find those x-intercepts. Where does this graph cross this line? I see it crosses at -1, and I see it crosses at +2. So that should be pretty straightforward. More of the same. Number 4, find the roots. Well, you should be noticing right away there's something fishy about this one. So I'll let you answer that one on your own. And that's actually the end of that lesson. So hopefully we'll be doing a little bit more of this in the coming lessons. I really feel that the graphing method is the strongest method of solving these equations, so we'll be using this a lot.